Titan is the only moon in a solar system with clouds and a dense planet-like atmosphere. Scientists think conditions on Titan are similar to Earth's early years. The main difference is that because it's closer to the Sun, Earth has always been warmer. According to NASA, in many respects Titan is one of the most Earth-like worlds we have found today. Yes, Titan and not Mars. An orange haze surrounding the moon kept its surface a mystery for Earth scientists until the arrival of the Cassini mission in 2004. Titan's atmosphere extends about 600 kilometers, which makes it a lot higher than Earth's atmosphere. Because of that, Titan was thought to be the largest moon in the solar system for a long time. It wasn't until 1980 that Voyager's spacecraft was close enough to discover it was actually smaller than Jupiter's largest moon, Ganymede. Titan's atmosphere is active and complex, and it is mainly composed of nitrogen and methane. Titan also has a presence of organic molecules that contain carbon and hydrogen, and that often include oxygen and other elements, similar to what is found in Earth's atmosphere, and that are essential for life. There is an unsolved mystery surrounding Titan's atmosphere. Because methane is broken down by sunlight, scientists believe there is another source that replenishes what is lost. One potential source of methane is volcanic activity, but this has yet to be confirmed. Titan's atmosphere may escape to space in a similar way than Earth's atmosphere does. The Cassini spacecraft has detected polar winds that draw methane and nitrogen out along Saturn's magnetic field and out of the atmosphere. A similar process is believed to happen on Earth with our own magnetic field. There is an abundance of methane lakes, which are mainly concentrated near its southern pole. And in 2014, scientists found a transient feature that playfully referred to as Magic Island. It is possible that nitrogen bubbles formed in Titan's oceans sit on the surface for a period of time, creating a temporary island that eventually dissipates. What is really special about Titan is that it has liquid methane and ethane lakes and seas, making it the only outer world in the solar system that has stable liquids on its surface. Large areas of the moon's surface are covered with sand dunes made of hydrocarbon. Because methane exists as a liquid on Titan, it also evaporates and forms clouds, which occasionally causes methane rain. Clouds of methane ice and cyanide gas float over the moon's surface. Sunlight is quite dim on Titan, and climate is driven mostly by changes in the amount of light that accompanies the seasons. Data also suggests the presence of a liquid ocean beneath the surface, but it is still to be confirmed. As more planets have been found outside of the solar system, Titan has served as a model of cloudy bodies. Examining the atmosphere of the moon has helped scientists to understand the atmospheres of these distant systems. In 2017, the Cassini spacecraft wrapped up its 2-decade-long mission to Saturn. Launched in 1997, the spacecraft arrived at Saturn in 2004. Upon its arrival, Cassini dropped the Huygens probe to study Titan by landing on the surface. The Huygens probe landed via parachute in 2005. Because of Huygens' observations, Titan became a top priority for scientists. The mission has achieved excellent results, such as taking the highest resolution images ever achieved of this moon's surface. During its primary and extended missions, Cassini was able to get fundamental data about Titan's structure and the complex organic chemistry of its atmosphere. It is because of Cassini's findings that scientists suspect the presence of an internal ocean composed of water and ammonia. The spacecraft has also spotted seasonal change, such as when an ice cloud formed in Titan's southern hemisphere in 2015. The focus of the mission, as it relates to Titan, was to find signs of seasonal changes and volcanic activity. Titan played a dominant role in Cassini's planned ending. The massive moon provided the gravitational boost the spacecraft needed to thread between Saturn's rings in its final months, exploring a never-before-seen region. The boost, which came more than 4 months before Cassini's suicide plunge, was the point of no return, increasing the spacecraft's velocity by approximately 3,000 kilometers per hour with respect to Saturn. It is thought that conditions on Titan could make the moon more habitable in the far future if the sun increases its temperature about 6 billion years from now and becomes a red giant. Titan's temperature could increase enough for stable oceans to exist on the surface, according to some models. If this happens, conditions on Titan could become favorable for some forms of life. Experiments on Earth suggest that Titan could be more habitable than previously thought. Complex organic chemicals, once thought to hover high in the atmosphere, may lie closer to the surface than estimated. As always, thank you for watching. Make sure to subscribe, and may the Force be with you always.